Hello, San Diego, and welcome back to another episode of Fleet TV, brought to you by your friends here at the Fleet Science Center. I'm your host, Ashanti, and in this week's episode, we are going to dig into engineering. First up, I'm going to send you to one of our resident Fleetsters who's going to show you a really cool demonstration of a pendulum, and then show you what happens when nature meets engineering.
Hello, my name is John Pop. I'm a volunteer here at the Fleet Science Center. I have here a device that I built myself and offered to the Fleet Science Center because I think it's kind of interesting and shows a motion that, well, it seems unusual, but actually there's very many versions of it that occur in nature quite often. I'm going to release this mass so I can show you that it's a mass hanging from a spring. Now you can imagine what's going to happen if I pick it up and let it go quickly from a greater height. You expect it to bounce up and down, but it's not satisfied with that. It also twists. And the twisting motion is now increasing. It's getting more and more twist, less and less bounce up and down. Now there's no bounce up and down at all. It was only twisting a moment ago. It's starting to bounce again. In a moment, it's going to only be bouncing and no twist at all. It cycles back and forth between these two different motions, in part because the masses on the side are adjusted in their distance from the center to cause the twisting rate of oscillation to be the same as, or very nearly the same as, the vertical oscillating motion. And that contributes to it going back and forth between these two motions. Also, and a little more critical and helps explain why it goes back and forth, is because when the mass stretches the spring has a tendency to uncoil, straighten out. That is, it twists a little bit, untwists you might even say, or uncoils. And that starts the rotating motion going. And with each oscillation up and down, a little more of the energy goes into rotating back and forth and less the bouncing up and down. And, well, you saw how it changed from one kind of motion entirely back to the other entirely.
Thanks so much, John, for that awesome demonstration. Are you ready for an engineering challenge? Can you design and construct a catapult using only recyclable materials? I bet you can, but you might need a little help from our friends in Studio X. Sending you now to Miss Akiko, who's gonna show you how you can give those recyclables a new purpose. Take it away, Akiko.
Hi everyone, I'm Akiko from Studio X, a makerspace inside the Fleet Science Center. Today, we are going to talk about making a catapult out of recycling materials. I have all sorts of wonderful things in here. So do you think you can make a catapult with the things you have in your recycling bin? To jumpstart your imagination, I will show you a fun game that I created. The game has two parts: a small catapult and a bunch of cardboard targets with point values on it. Here are the tools that I use for this project: a pencil, a pair of scissors, and hot glue gun or tape. I also used a ruler, a marker, and coloring pencils. A catapult is basically a device that stores energy, and then when you launch an object, it converts that stored energy into motion. So which material we have in here springs back quickly and releases stored energy? I cut out a strip of plastic from one of the plastic containers. Next, I built a structure that will support the plastic strip. I cut the toilet paper roll in half and cut small slits to create glue tabs at one end of the paper roll. Then I cut a longer slit at about 45-degree angle to insert the plastic strip. Can you guess why the slit is tilted at an angle? Here I'm using hot glue to assemble all the pieces together, but you can use tape too. To make a small lightweight object to launch, I scrunched up a small piece of paper and made a bunch of paper balls. A bottle cap works as a bucket to hold the paper ball, and I used the leftover toilet paper roll to create a container for the projectiles. For the targets, I used thin cardboard to make some self-standing figures. Does changing the shape or size of the plastic strips change how it springs back? What other types of targets can you make? A famous inventor, Thomas Edison, once said, "To invent, you need a good imagination and a pile of junk." I don't know what kind of junk he had over 100 years ago, but we have a lot of wonderful materials in our recycling bins today. So have fun building. Thank you so much for watching and hope to see you again soon.
I hope after that how-to, you are thinking challenge accepted. Channel your inner engineer and get creative with those recyclables. When you do, make sure to share them with us. We love to see how you STEM. Now sending you to Vanessa, who's going to share with you her experiences as a civil engineer, as a woman in STEM, and of course, share some tips for anyone who might be thinking about taking a deeper dive into STEM in the future.
Hi everyone, my name is Vanessa and I am a civil engineer. My journey to civil engineering started at Palomar Community College, where I took my intro to engineering courses along with my math and physics courses that really helped me learn the basis of engineering. After transferring over to San Diego State University, I got really involved in the American Society of Civil Engineers, and I have loved it ever since. I really think that getting involved in organizations has helped me become the civil engineer that I am today. As a woman in STEM, there are very few girls that were in my engineering courses. Although that can be intimidating, I didn't let that discourage me from achieving my goals. If you are interested in becoming an engineer, I highly recommend just keep going and dream big. It may be difficult at times, you may fail sometimes, and that's okay. As long as you just keep going and pursue your dreams, and you can make a difference in the world. And that's why I decided to become a civil engineer.
That's it for us in this episode. We hope you are not only feeling inspired to be an engineer, but maybe by that engineering challenge. So you know what to do. Share us with your family, share us with your friends, like us on social, and we'll see you next week.